Artificial intelligence has the potential to generate more than $1 trillion in AI-related infrastructure spending in cloud and enterprise data centers over the next 5 years. As a consequence, the integration of AI into data center operations is set to significantly transform the landscape of capital expenditure and infrastructure development across the globe. To discuss more on this, I'm now joined by Harqs Singh, CTO of InfraPartners, which is on a mission to change the way data centers are built to make them more efficient, more affordable, and more sustainable. Harqs, thanks so much for talking to me. Last time I saw you, we met at the International Finance Forum in London last May. We are truly on a race to 2030 to really make sure that these big infrastructure beasts become sustainable and they really serve their purpose, which is to upkeep the digital economy. If you look into your present and future crystal ball, if that makes sense, what are some of the pressures that the data center industry is under at the moment?
Well, thank you for having me, Joel, and glad to be here. You're right, it's a very exciting time for our industry and for the world, I think, with the rollout of Gen AI and what's happening now. In terms of the pressure that's creating for our industry, the demand is far outstripping supply. We see a lot of pressure on building, constructing data centers. You mentioned the investment that's going on, which is significant in this space. And so what we've seen around the world as we look at data center projects, there's some challenges. So there's labor shortages. There's a global labor shortage of key skills that's led to projects being delayed, whether that's electrical skills, mechanical, GC skills. And some parts of the world don't even have the skills available. And so there's a labor shortage. The second thing is we know a lot of people are looking for schedule certainty. And at the moment, there's a lot of projects that are delayed, especially outside the US. And this is all before this AI wave of growth is coming. And so it's only going to make these issues worse and these pressures more acute. And this is where really InfraPartners is making a difference. We're solving for these problems around labor shortages and schedule certainty by building prefabricated modular AI data centers, which can be shipped anywhere in the world. We're focused on supporting NVIDIA and AMD GPUs, essentially. And our focus is around how do we scale, how do we grow, and how do we accelerate time to revenue for our clients?
I think as well, maybe something to set the scene as well on top of what you just said, is we often talk about these AI data centers and these big machines and the way it's going to work and the different ways it's going to work. But what would you say are the key differences between an AI data center versus a traditional facility? And what specific features do you think will really become standard as we head towards the end of this decade?
No, that's a great question. Legacy data centers cannot really support this type of infrastructure in an efficient and effective manner. So we really need to redesign the site specifically for GPUs. We're building AI factories, AI data centers now, and they're very different from the CPU infrastructure data centers that were built in the past. And so it's a completely different type of IT. Moving to GPU computation, we've got training workloads, we have inference workloads, and the constraints are different. And so we need to design differently. So what does that mean? It means different power designs. It means much higher densities, over 100 kilowatt per cabinet for the current generation of GPUs. Future generations are looking at more like 250, 350 kilowatts per cabinet. These are densities that we never thought about in the past. There's a completely different cooling technology. Liquid is going to be a given inside the rack with rack manifolds, CDUs, quick connectors, drip trays. In the IT space, there's going to be different resilience designs for power infrastructure, for backup power. The racks themselves are much heavier. So you need to design the structure of the data center very differently. The shape and the scope of a module that we're building at InfraPartners is really optimized around what we call the GPU block, which is trying to get the most out of the GPUs performance-wise as you can, connecting them together. So the network design is very important. And that's exactly what we're focused on, is how do you optimize across all these areas for this new type of design? We are fundamentally changing the design of data centers going forward. And it's an exciting time for us to do things differently, using innovation and help being part of the journey around how AI is enabled and used around the world.
Yeah, I think really one of the most exciting things about this new wave of modernization of the data center is that it's not just a technology upgrade. It's also an architecture design. It's the visual side. It's the cement. It's what goes actually inside the building to build it. So I think that's quite fascinating to be part of that journey now.
Exactly. It's a complete change of the whole stack. And so it's going to allow us to do things very differently. And I'm very optimistic around what AI is going to enable. not just across our industry, but across every industry. And so the benefits, to your point at the start, there's trillions of dollars worth of value here if we can unlock it in the right way.
I mean, I mentioned 1 trillion because that's the recent stat that came out, I think, by the Delaware Group. But we've heard before Digital Bridge talking about $4 trillion across the globe even shorter than 2030. Not just in data centers, other infrastructure, but it's a multi-trillion-dollar economy. It's a giga-scale economy, trillion-dollar economy. It's no longer the $100 million deals that we used to look at 8 years ago. But you call them AI factories, actually, and I really like that because I think as we head into all this, we're also facing a lot more public criticism into what these facilities are and what they do, what they look like, the noise they make around neighborhoods. So maybe by calling them factories, actually could be an easier way to break into the general population and explain to them that this is just a new industrial revolution. But I think probably one of the big aspects of it as well is that the last industrial revolution was quite polluting. This one cannot be as polluting. So I mean, when we look at building all this, and we keep hearing about energy consumption, water consumption across data centers across the globe. You look at Asia, the numbers are not as good as Europe, but Europe is also not the best. If we look at the US, there's places that do better than others, especially in Nevada. I mean, if you look at sustainability, what would you say would be the key areas of focus that we need to have now as we're building them now? We need to have to really ensure that by 2030 we are, if not 100%, I don't know, 80, 90%. Actually, one step back. Do you think it's achievable to be renewable, sustainable, 100% sustainable by 2030 in our space?
That has to be our goal. That has to be our objective as an industry. Look, I think if you think about a couple of years ago, nobody was talking about 100 kilowatt cabinets. Nobody was talking about gigawatts of data center space. Nobody's talking about trillions of dollars worth of value from this new paradigm or hundreds of billions of dollars of investment in the data center industry. And so, things have changed a lot in the last couple of years. Now, in terms of our power projections, we show a significant increase by 2030. We think around 50 gigawatts of growth of data is going to come in the next, 6 years or so. So what does that mean? It means there's a huge opportunity for us to do things differently. We need things like small modular reactors. We need to look at different things like long duration energy storage, new battery chemistries, sustainable fuels. All this technology, which has been, bubbling along, we need to accelerate. We need to accelerate the development of everything. And, we need to, as an industry, adopt and drive some of these changes and be a little more risk averse. And this is an opportunity to do that. So by 2030, doing this in a sustainable way has to be our target. But the only way we're going to get there is by accelerating a bunch of innovation that's taking place and thinking about things differently and in a new way. And so that's the challenge we all have. I'd love to say we can do all of it sustainably. And, I think if we're in 2031 and we do this interview again, and we say we've done it, I think we deserve a big pat on the back as an industry. But I think this is where we need to step up. We are an enabler of this AI revolution. And I think you've got it right. It is a revolution. And so, as we look more broadly, and I think something we need to not forget, this growth that's coming, there is real value at the end. AI itself can be really disruptive. Obviously, there's some negative implications which we need to manage and put controls in for, but there's also a huge amount of opportunity, right? There's significant productivity increases if you can see, in sort of knowledge-based workers, what Gen AI is going to do. If you look at things like material science, there's new materials that are being created through Gen AI, which we haven't envisaged as humans, and that could create and change the boundaries upon which we live life. In the healthcare space, you think about what AI is doing in diagnostics, robotic surgeries, in the customer service space, chatbots, virtual assistants, entertainment, content creation. You got AI generated art, you're going to have AI generated games, videos. Every industry is going to be impacted by AI. And it's our role to make sure the positive use cases deliver far more value. We put in, like I said, controls for some of the negative use cases that could come about. But this could effectively change things for everybody on the planet. And so that's why it's exciting. And we, as an industry, the data industry, is an enabler to that. And so, no one was planning to build tens of gigawatts of data center capacity, but that's our challenge now. That's the challenge for the next wave of change. And so that's why I think is really exciting. And we're going to have to, really step up to that.
Yeah. Well, but it's a challenge, but everything you said is a gigantic opportunity as well. There's a lot of business to be made there. Not just in one part of the stack. It's the entire stack of the data center, from the architect to the engineer to the construction company, and then of course to the hardware guys, north, south of the rack, all the software that's going to come in, and then once you put that out to the world, then all the industries that you mentioned, and many, many more. I mean, you look at Hollywood, everything's changing. You look at healthcare, life sciences. We've seen what Pfizer did during COVID, during those 6 months with supercomputers in Germany. I mean, we see the giants of beauty using supercomputers instead of animals to test their products. So again, that also protects animals more, in a way. I mean, whatever you look at, there's good examples. We are very good at focusing on the bad ones. That's human beings. um,
And then, I think the data center industry needs to evolve. We need to build, hugely scalable solutions, right? To get to gigawatt scale. We need to mature as an industry and industrialize for rapid manufacturing. We need to make sure that we enable these AI models and benefits for all countries, but for all of humans as well, right? So we can collectively, use the creativity of all of human population to change the world. 35% of the world is difficult for data centers to be built in, whether that's for skill shortages, whether it's a challenging business environment. But some of these are the biggest growth economies and opportunities. And so, what we're doing in InfraPartners, the solution we're building, is something you can ship anywhere. And that's been one of our really strong use cases is, 35% of the world where it is difficult to do business in for whatever reason. Our solution works well there because you can build it in a centralized way, ship it across, and then simply connect it together to have capability in the country. And so, I'm a big fan of we need to create an abundance of everything. I think that's what our responsibility is as this generation. We need to create an abundance of food. We need to create an abundance of energy. We need to create an abundance of compute capability. Because what I believe is when you create an abundance of something and then you give it to very smart people, they will create magic. If you think about Gen AI, why did Gen AI come about? It was for two reasons. The cost of GPU compute came down, and the amount of data that was out there publicly available was big enough for the models to be trained on. And so, there was a lot of conversations in the past around, should we constrain, what people are creating? But if we were to constrain the data that people are creating, we may not have had Gen AI. And so I'm not a big fan of constraining things. I think we should manage things so we're not, being too frivolous. But my view is we should create an abundance of everything. And then the next generation, we should give them access to this abundance and say, what can you create from this? What magic can you create? How can you change the world, humanity, and the rules that we live on? And so I'm a big advocate of let's enable the creation of an abundance of everything.
I love that, the abundance of everything. I think that puts it very well. And I mean, and it's truth, because if you look at where the capacity is at the moment, it's mostly in the northern hemisphere, all the way from China, all the way to the US. But most of the population actually lives below the equator line. So if you offer them the tools to create new things, I mean, if you look at India, if you look at Africa, Africa's 1 billion people, is going to be 3 billion in the next few decades. India is going to grow to 1.6 billion. If you look at South America as well, it's going to grow, I don't know to how much, but closer to 1 billion probably in the next few years, few decades. I mean, if you give them the tools, that's where the new Microsofts, the new Googles, where the new, whatever you can think of, that's where the new opportunities could be and will be. There'll be more competition on the global stage, which is going to speed up innovation anyway. Because then once the northern hemisphere has to compete with the southern for innovation, I mean, you can think of driverless cars, you can think of whatever you want to think. Even the space race, we will evolve even faster as a human species. So that's going to be quite interesting to see. But then I guess, so, and building up quite a lot now into the challenge side of things, of course, all this is creating a tremendous growth in terms of AI workloads. And we are seeing operators kind of trying to embrace this, but you've already mentioned as well, the legacy data centers are harder to do it, to do so. And I can only imagine the OpEx that goes into doing it. How can the operators manage all this, and especially the more established players? How are they balancing this out? I mean, are we going to, picking up a very clear example, if we look at the biggest players, the Equinix, Digital Realty, Cyrus One, QTS, which have vast portfolios of real estate across the globe. How are those properties going to be fitted for this? Or we're going to have two types of services where we carry on with the legacy infrastructure, we let it run until it kind of goes off, and then they start building these new ones. So you're going to have two levels of service, one for traditional enterprises, one for people focused on AI workloads. I mean, how is this all going to make sense?
No, it's a great question. We have obviously built a lot of data centers, over the sort of previous periods around, colocation sites, obviously the cloud growth that came. And so to your point, there is a lot of data centers that have been built around the world. But the projections going forward, the growth, is equal to, if not greater than the amount of data centers we've already built. And so I think what we need to be thinking about is how do we use, whatever we're building, how do we make sure that we can upgrade it? There's upgradability, there's real life cycle management. And there's, flexibility is probably the word I hear the most, is we need to build for flexibility. And why do I say that? Think about 2 years ago, nobody was thinking about 100 kilowatt cabinets. Nobody was, apart from some niche use cases, was using liquid to the chip, right? Nobody was talking about 300 kilowatt cabinets. Now that's a reality today. And so we build these data centers for 10, 15, 20, 30 years, some of them. And so the idea is there's multiple generations of IT equipment that goes through them. So how do we build in a flexible way such that we can create upgradability and lifecycle management? And so, one of the things we're doing at InfraPartners is, you could design a module with us today, a design which is based on the Blackwell chips, NVIDIA. And that could be your version 1 design. And you could deploy, say at a 100 megawatt site, you could deploy 50 meg of that. And then, Rubin platform comes out next, which is going to be higher density. And again, it's going to have different constraints. And therefore, you could design a version 2 with us and deploy the next 50 megawatts using the Rubin platform. And so that modular way of building gives you that flexibility. I'm not saying it's the only solution, but I think we need to think as an industry more flexibly. And then how do we upgrade things? The other thing we need to bear in mind is, how are the workloads going to change? Which workloads are going to be disrupted by AI? Now, search is one of those that is going to be disrupted. But as you start to look through the other use cases and workloads, you need to work through how much of those are going to be disrupted by AI. Like, is AI going to actually take over all of CPU compute? That's not what we see right now. We see it's net new and additive, and actually there's new use cases required. And so it's going to be really interesting as you look at this holistically going forward, how the workload's going to change. We think it's more net growth, if anything else. And then, like I said, is you need to think about these sites in a way, how can you upgrade them? And now with the modular thing, one of the things we're looking at also is, you can create a version 1 of your design. And then as we're sort of 5 years down the road, we could potentially take that module back and refit it for what the new design is going to be in 5 years' time. So having something built in a modular way, not just the way we do things, but generally, is going to allow you to, is going to give you the most flexibility. And I think flexibility is key right now, because truthfully, none of us know how this is going to evolve. We're very early in this AI game. If I use a football or soccer analogy, we're sort of 3 minutes into the game.
Oh, wow.
And we're trying to predict how it's going to end. And the truth of it is none of us know. None of us know which model number will we get diminishing returns. Is it ChatGPT 5, 6, 7, 8, 9, 10? When do we get to a point where the sort of prompt responses are of 99.9999% accuracy, and actually going to the next model is diminishing returns? We don't know that yet. We're very early in the game. And so the big thing right now is flexibility and being able to evolve with how NVIDIA and AMD are doing things, and we keep tightly aligned with their roadmaps. And so that's the idea, is we need to evolve, and we need to evolve with the industry. And so it's an exciting time. There's a lot of value to be had here. There's a lot of change. And so, it's one of those things where flexibility and, trying to put that into a 30-year asset is the challenge. And that's what I would industries think about.
And I think it'll be interesting as well to look into how data centers will end up actually embracing AI for themselves, because you don't need to run at 100% all the time either. You can balance the workloads as the peak wave comes in, bring things down, especially the energy consumption down when there isn't a lot of use. Almost like people use their washing machines at home. Like it's cheaper at night because there's less people using energy after 10 p.m. So those kind of things would be interesting to see
Yeah,
in
we
the data
actually see the other
space.
thing as well, where actually there is, the way some of these sites are being designed is you may overpower some of the sites to
Mm,
overclock the GPUs to get more performance at certain times when required as well.
okay.
And so, I sort of allude to this being a bit like an engine, right? You might put it into power saving mode or economy mode, right?
Hmm.
But you also might put it into sports mode because you need more performance, right? And so these AI data factories of the future are going to be more like an engine. You put data in, you've got your engine, and out of it comes, you know, comes your responses and your models. And so it's literally is going to be, you're going to have different modes to it. And so we're seeing some really interesting changes in design parameters that are coming through, which means these are going to be managed and built very differently.
Hmm.
So the whole stack will be more tightly aligned going forward.
Hmm.
The hardware, software, right up to the stack, right to the energy piece, like you said. For training, there'll be gigawatt campuses. And these gigawatt campuses will be very closely tied to energy sources for high efficiency, low cost. And then there'll be inference. And the inference sites these will be smaller distributed sites close to network, close to high population centers. And this is where AI will be monetized, is on the inference side. And they will rely more on either some on-site power or utility grid, but they'll be much smaller. And so it is going to be a different paradigm shift, but one that we need to enable because there's huge benefits, trillions of dollars worth of benefits. And like you said, there's multiple different sources that have come out with, some multiple of trillions of dollars worth of value from this. And that's based on what we know so far. I believe there's a lot of use cases that we haven't even scratched the surface of.
We can't even think about them.
Exactly.
It's are those inferences what you mean by edge computing? Because this is the word that everyone has different a different definition for. Um, yeah, that's what you're talking about
I
with
think it's an
inferences.
evolution of edge.
Okay.
I think it's in the financial services industry, you've had compute close to traders for a long time because latency has a big impact, right? High frequency trading, and so for that use case, it works. This is, I think, another use case for having GPUs and inference close to users, is to have really quick response times to users, and so I think this it's all about where does compute and data need to sit to provide the service to consumers. So, for example, the gigawatt campuses that are doing training, they don't need to be near users; they're training models. You know, Also, there's questions of, do they actually truly need backup power?
Mm,
You can bring some of these sites down gracefully, and so you may not need to have backup power generation. But whereas the sites that are close to users, if you're prompting Joao on the model you like,
mm,
and it's taking either too long to come with a response, or it's dropping your response, from a service perspective, it's not going to be very good, and you're going to wonder why you're paying for that, especially if there's true competition in the market. And so providing something on the inference side where the client and customer experience is positive from a response perspective, but also from a timely, quality perspective,
mm,
latency perspective is going to be important. And so that is a differentiator. So there, the design is going to be slightly different as well. Um, but like I said, we're early into this game. There's been a lot of debate around, is inference and training going to be the same size, or is inference going to be smaller? Is inference going to be bigger? And it's really interesting. We're having conversations around the size of training versus inference. Now, training is sort of gigawatt campuses. And a few years ago, when I was talking about this, it was like, hey, inference is going to be smaller. Then there came a point where they said inference is going to be the same number as training. And now the thought is actually it's going to be bigger than training.
mm.
So, as I said, things are evolving and maturing. And I think it's best not to get stuck on something and say this is the way it's going to be. I think you need to be learning about what's happening in the market all the time and evolving.
Mm.
And that's why flexibility is very important.
Yeah, it's definitely changing. I always like to say that even people that just start now, they're coming at a time where everything's changing so much. If you weren't here 6 months ago, you can very quickly catch up to the present day. The rest is history. But I want to maybe mix two things together a little bit because I think they go hand in hand. Because you were talking about flexibility, and we know flexibility on the investor side. It's something that sometimes doesn't play out that well. They like things a bit more established, more black and white on paper. Um, how can data center operators kind of manage that? in terms of explaining to the investor community, we need flexibility to roll all of this out over the next 10, 20, 30 years. But then again, picking up on the energy aspect of it as well, because that's the big part of all this. There is the run on energy. What can they do to ease their mind?
I think a lot of the focus right now is finding locations that have power. I think that's the key enabler right now, to your point, in terms of being able to be an unlock to building an AI data center. I think the flexibility point with investors is that we're going to build the solution in a flexible way, such that if the next generation of GPUs are 350 kilowatt a cabinet, that we actually have a solution that can evolve to that. And so that's where I think the modular piece comes in really well, where I say, you create a version 1 design on Blackwell, then you can create a version 2 design on Rubin, and that's okay, and it can fit within the same site. So from an investment perspective, you're not losing anything. I think the other thing that's key for investors is making sure managing the risk. So make sure that the investment is risk adjusted. And so that means understanding really where the market is going, and building in the right places. And I think that's going to be the key thing is, expandability, flexibility, and building in places where, training and inference actually has an impact and is in demand. But right now we're in a place where demand is far greater than supply. And so, I think, we need to build a lot faster, a lot quicker. And that's where the InfraPartners solution comes in.
Yeah, we are in a perfect storm where actually the business case puts itself forward almost by itself. And then, so Harqs, just to quickly kind of summarize everything we were talking about, if you had to choose, I don't know, 3 top technologies that we really need to be embracing right now, as we put shovels to the ground and build these new facilities, what would you say that we need to be putting into these AI factories?
So I think there's sort of 3 levels of innovation and optimization that we need. So one is sort of higher up the stack. So we need, optimizing number representation calculations, optimizing GPU performance per watt, optimizing GPU chip improvements and making improvements there, high bandwidth memory, faster network fabrics. So I think there's this whole piece on the IT side, which needs to really keep innovating. And it just needs to keep growing as fast as it can to create innovation so that actually we don't have to build as much, right? We don't have to build as much data center space for the same performance. The next space is the data center space. I think we need to be looking at new innovations. We need to be open-minded about adoption. We need advanced data center designs. I'm a big believer of, this isn't it needs to be solution A or solution B. Where we are right now, I think we need to do everything. So, we need to do, self-build, stick builds. We need to do, using co-location facilities and third parties. We need to look at modular as well. Like everything needs to be on the table to be able to solve this challenge for the world. And, the overall pie is getting bigger, and we're growing, and this will float, raise the water level for all boats essentially. But I think we do need to look at adopting new innovation and changes to be able to get there, to be able to keep sort of on top of the growth. And the last thing is in the energy space, looking at things like SMRs, looking at things like long duration storage, and keeping aligned to things, microgrids and changes that are happening in the energy space, because you need these 3 things to come together for you to have these AI factories. And so, we all have responsibility. Our industry has a responsibility. The chip manufacturers have a responsibility, and we need to be very close partners with the energy producers as well, and have a responsibility to make sure we have the power that we need to. So it's at those 3 levels that we need to see great innovation and change over the next 5 years. And like I said, I think it's a very exciting time for the industry, and it's the next wave of growth, and we can be a big enabler of that.
And not just for us, but the entire world. And it's no coincidence that energy and data centers, even within the larger digital infrastructure space, especially data centers, are the 2 main categories for investor deployments in the world right now. It's and growing at double-digit rates across the entire globe. So I don't know if you're going to add anything else.
No, I think you're spot on.
Okay.
I think this is something we could create for all of humanity. We can unleash a lot of creativity, and that should be, our role here is we should be the great equalizer in the sense of being able to provide these AI capabilities to everybody, the whole of humanity. And then, you know, we sit back and see what magic is created by this next generation and what they're able to do with it through an abundance of everything, like we mentioned.
Yeah, let's put in the next 20, 30 years of work, and then we can sit back, as you said, and just watch what people do with it. But Harqs Singh, CTO of Infrastructure Partners, thank you so much for talking to me. As for your home, thank you for watching, and do check our social media and website for more on digital infrastructure breaking news and features from across the globe. At the Tech Capital, you lead, we report. Bye for now.